When you guys did direct variation a while ago, sorry, the handwriting was really bad. When you guys did what was called direct variation, you'd say y varies directly with x. And what it would look like was that means there was some constant being multiplied by every value of x. So y equals kx is, ooh, move this around here.
Constant
This
starts
is,
with C.
they use k's for this stuff. The,
Check.
that's what that looks like. Y varies directly with x. That means every value of x is being multiplied by some constant to generate some value of y. That value of k, obviously it's a constant, so it is constant. This was the precursor to slope. You guys saw these as y equals 2x. And when you first learned how to graph and work with slopes, you realized that you would make a table and you'd substitute in to generate your y value. That constant is what you were multiplying everything by to generate the y. So if you use your values, 1 times 2 is 2, 2 times 2 is 4, and so on and so forth. As you guys learned to graph that, you learned that it was the rise over run. That's what direct variation is. Direct variation was the precursor to slope. Does that pseudo ring a bell? It's probably been a few years since you've seen it. It's not something that's really taught a ton. It's one of those things that, depending on when you took algebra and with what book we still had at that point in time, you may or may not have seen it. So, the inverse variation is just the opposite. Inverse variation, y varies inversely. That just means y equals k divided by x. The constant is now the numerator. Yes, sir? Some constant. K is any value not equal to 0. Same idea. If I had an example where it was y equals, well, I'll use 2 again, 2 over x. That just means that in order to, when I take a value of x, in order to generate y, I have to take 2 divided by x, 2 divided by 2, 2 divided by 3, 2 divided by 4, and so on and so forth. What this allows you to be able to do is graph things differently. We're going to start looking at graphs of inverse functions. They might do stuff like this. Okay, they might have different tails and whatnot.
Do I think it's 0? Wouldn't y equal 0 here? X and y is 0?
Yeah, if k is 0, everything is 0.
But it says it can't be 0.
Well, yeah, that's what I'm saying. It can't be 0 because then you won't have anything. Because then there would be no variance. K is 0 is just 0. The mathematical for all that's a lot. That's why they're putting it like that. Basically what happens here is that we're going to take this equation, well obviously y varies inversely with x, just means y divided by k, or y equals k divided by x. We're going to take this generic equation and look at tables and just, if I can talk, decide whether or not something is direct variation or inverse variation. It is very simple to do. Okay? So let's look at an example. If I wanted to classify whether it's direct variation or inverse variation, both of those equations have y by itself. Do you agree?
Yeah.
So basically that means you're going to take any of these equations and solve for y. So if I have y divided by 5 equals x, and I need to get y by itself, what do I write? Multiply each side by 5, and I get y equals, is that inverse or direct variation then? Direct variation, because it's multiplied. That's correct. Okay. Oh, logarithms are so much fun. y equals x plus 2. Y by itself? Okay. Direct or inverse? Or neither? It's neither. Because of the plus sign.
Y must be a very lonely variable.
What's that?
Y must be a very lonely variable. It's always got to be by itself.
Well, why does it?
Never mind. Never mind.
I thought you were saying
There's a
why,
joke. You
why.
didn't hear it. It's fine. It's over. It's all over.
Sorry.
It's all over.
Yes, it's all over. It's all downhill from here. And lastly, x times y is 4. Very good. You divide each side by x and you wind up with y equals. Therefore, it's inverse. Okay? That's what inverse variation would look like. Okay? And like I said, as we get into this a little bit more, you'll start to see how we're going to set it up, how we're going to solve it, just by looking at a lot of the tables and whatnot. Okay. Did that. So let's look at this table and decide whether or not it's direct, inverse, or neither. I realized I should have changed this to x, y. Okay. So if something is going to vary inversely, it's going to follow the pattern that y equals k divided by x. If it varies directly, it's going to follow a pattern y equals k times x. In order to tell whether or not it is, what we're going to do is substitute the values for x and y and solve for k 5 times. If that value of k is the same when it's inverse, it's inverse. If it's the same value for direct, it's direct.
Yay!
Which means, let's solve the generic equations. Bless you. You ever heard of solving what's called a literal equation before?
No.
You've done this. Solving a literal equation, for example, distance equals rate times time, right? If I'm going to solve that for rate, what do? So solving a literal equation is just solving for an independent variable. Solve that equation for k on the left. What do? Divide or multiply?
Oh, I'm sorry, I was looking at it.
It's your other left.
All right.
So if it's inverse variation, x times y would equal k. If it's direct variation, y divided by x would have to equal k. So we just go through our list. Oh no, what is 2 times 9? Oh no, what is 4 times 4.5? Well, double 4.5, what do you get? 9. Double it again, what do you get? What's 6 times 3? I'm going to take a guess. What's a fourth of 8? 2. So yeah, 2 times 8 is 16, plus 2 more is 18. Oh no, 10 times 1.8. I don't know if I can move my decimal. So guys, what do you think this is going to be? Direct or inverse variation? It's going to be an inverse variation. We're thinking a k value of 18. So this table has a k value of 18. And it's inverse, so it means the equation would be y equals 18 divided by x.
Yay!
That's really all there is to this. You're going to check to see which one of them works, whether it's going to be inverse or direct variation. Shinki, you don't look like you believe me yet. I'm sorry. Yes, sir.
That's weird how like direct, when you like solve for a certain variable, looks looking like inverse.
Because they're inverses of one another. Convenient, isn't it?
Oh,
Huh?
no,
Okay. Figure this one out. X and Y. Tell him that there's a second part. I was about to tell you there's a second part to the test. That wasn't nice. Same idea, guys. Set it up as, inverse is y equals k divided by x. Direct. And just check to see which one works. Really? Really? What's 10 times 30? What's 20 times 15? What's 30 times 10? What's 40 times 7.5, you think? Well, what's 4 times 7? 28. Okay. And then, what's 50 times 6? So do you think it's going to be direct or inverse? I was just shaming you. You weren't the only one that had the calculator out doing that, but as soon as I saw you were that close, you got the shame. It's going to be inverse again, guys. You have a constant value here of 300 divided by x. Okay? Nice you. Yeah, it's just like that. Huh. Yes.
so you just plug in.
I'm not plugging anything.
I'm so confused.
I'm just multiplying out. Just multiply everything together.
Okay, but like, okay,
Thank
so
you.
for 10 and 30, where would you put that or use equation?
Remember, I'm thinking this in terms of, I'm being very literal here. Okay? If for all those ordered pairs, you multiply them together, you get the same number, that's all it is.
Yeah, but that's what I meant by plug in. Like plug
Or
in the
substitute.
Same thing.
No, it's not. How are you going to substitute in the electrical outlet?
You substitute
Yeah.
So then the answer would just be it's an inverse variation of the value of the
That's it. Yeah. Let me show you another thing that will happen. We don't need to do another one of those tables. Another way that they'll write this out is we're going to ask you to write an equation. Basically, it's a two-part problem. We're going to have something like this where they'll tell you right off the bat that variables x and y vary inversely. So when you see that, that means y varies inversely with x. So if it varies inversely, the equation would be y equals k divided by x. Okay? It varies inversely. And then it tells you when y is 8, when x is 3. So if y is 8 when x is 3, we need to figure out what that constant of variation is. What's the value of k? So we substitute and solve for k. What do you get for k? 24. So that means my k value here is 24. Which means I can write it out in terms of an equation, y equals 24 over x. So in part B, find y when x is negative 4, utilizing what you just solved as your constant of variation. So if your constant of variation is 24, what's y when x is negative 4? Negative 6. When you substitute negative 4 in for x, you just divide out. Shinky.
Wait, so if it doesn't work when we multiply 2 times 9, like, you know how we do that and say it's all equal 18, then we just go through the division and see if it's what?
It's going to ask you, is it direct or is it inverse? So you just
So-
check it. That's all you're doing.
Can it be negative?
Yes, it could be. It could be negative.
So then you have to check both to
Yeah.
make sure it's not negative.
Yeah, it's usually what happens. I mean, it's pretty quick usually.
Okay.
Okay. So x and y vary inversely. When x is 1/2, y is 10. What's y when x is 2? So if they vary inversely, that means we have y equals k over x. So that means the first thing you got to figure out is what's the value of k. So we substitute. She's getting mad. And solve for k. Remember earlier when we figured out if it was inversely, if you solve the equation literally, you just multiply both sides by x. So what's half of 10? 5. So your value of k here is 5.
Are you supposed to multiply by 2 to get rid of it?
Remember, if I take the literal equation here to solve for k, it's y times x equals k. I'm not multiplying by 2 because if I'm multiplying by 2, that means I'm just dividing by 2. Here I'm dividing by half.
Oh.
Why don't you just write it as 5?
So it's not the way the world works.
You're still doing that.
Yeah, still have to do the find k. So now, jeez, why is it so slippery right here?
Because it's covered in baby oil.
For some reason I was directing me. So y is 5x. You just leave it like that if you want, it's fine. That's all there is to this, guys.
Wait, so y is 5
Yes.
So, when you do the first, like, half of it,
Mhm.
and you have the y equals x, or a k over x, you have to make it like that first, the other form next to it, and then you have to put it.
You don't have to do it that way. It's just if you already know that's inverse, because you're going to have to solve for k, you might as well just know. You just should know that you're just going to multiply them together.
Why is it?
Wait,
It was given to you.
Oh, I was thinking the x.
Yeah, no, it'll ask you just like this. It'll give you those two, and they'll, guys, it'll give you the first part, and then it'll ask you to solve.
I just thought like you had the 2 in there, it's like I was half, and I was like, I'm so lost.
No. All right.
Let's get some cookies.
Joint variation. Joint variation is just instead of being inversely, joint variation just means you're multiplying more than one thing together. So z varies. If I say z varies jointly with x and y, Joint variation is just multiplying everything together. There's still some constant involved. There's always going to be a constant involved. This just means z equals k times x times y. If they vary jointly, you just have z equals some constant times the two variables they give you. Yes, sir?
Are we going into three-dimensional graphs now?
No, not yet. That's something we kind of taken out of the curriculum. This is kind of where you could get that from, of how you can generate that third ordered pair if you had to if you had a constant thrown in there. Thank you. But we're not worried about that. We might do a little bit of it towards the end of the school year if we have time to kill, which we probably will. Martin?
So could you have like y varies jointly with x, and then it has to be x and k?
Yeah, you can do it. It's whatever comes first is one on one side, and then it's just the other ones on the other.
And by saying jointly with, it means there's also k in it?
Yes. Well, k is always in everything. All this
Okay.
variation, k is going to be in everything. It's just whether or not you're dividing. If it's inverse, you're dividing by the variable. If
Okay.
it's jointly or direct, it's always multiplying.
Thank you.
So it will look like this. Another one that will come up is, let me write this one out. Z varies jointly with x and y squared. Or z varies jointly with x and y, and inversely with w. Might as well. So I'll throw a couple weird ones at you. So if I say z varies jointly with x and y squared, that just means you're multiplying two things together. The two things you're multiplying together are going to be x and y squared. What's going to have to be with it? Okay, that's it. Because it's variation, so if z varies jointly, that means z has to equal some value k times x times y squared. Correct. And that's why I said and y squared. I would say the quantity x, y squared is how the other way would be written. Now, z varies jointly with x and y. Yes, ma'am?
Is it kxy quantity squared or kx and then y squared?
Y squared. I'll
So
say,
y is the one
it'll say if it's x and y are quantity squared, it would say z varies jointly with the quantity x and y squared. 'Cause that's how you put it in parentheses. But if it doesn't, it's just y. The last one there, z varies jointly with x and y and inversely with w. Done. She got like mad about that too. So z varies jointly. That's sort of ugly.
So throw it over there.
That's it. You can pick them apart just like that. You can pick them apart just like that. It's nothing too crazy, nothing too nutty. It's just a matter of following them, how they write it out. It goes by real fast. Yeah, you might. Depends on what they give you. If they say z varies jointly with k, x, y, they'll give you z, x, and y. Then you can find k, and then you can go ahead and find some other ordered pair or some other value.
So it's like the a and the y equals a, x minus y.
Very similar. Very similar. Like I said, when we walk through this, don't write all these things out. This is right out of your book. Y varies directly with x. There's the multiplication. Inversely, there's your division. Jointly, k, x, y. Inversely with the square of x. Inversely, so it's division by x squared. And we just did one direct and inverse. It's as long as you have whatever this variable comes first is on one side, K goes on the other, whether you're multiplying or dividing, just depends if it says direct or inverse. That's really it. Do those.
We found